Hi everyone, welcome to this playlist of mathematics videos dedicated to the correction of the Moroccan Baccalaureate exam June 2017. We are going to treat a classical problem on functions and sequences. For more profit, pause the video, do the exercise, and then compare with the proposed solutions. Part 1 of the problem. Question 1 is easy, just use ln of 1 equals 0 to calculate g of 1. In question 2, the given variations table shows that the function g is strictly increasing on its domain of definition 0 plus infinity. So g ranks the images in the same order as their antecedents. In the first case, x is less than 1, so g of x is less than g of 1. And since g of 1 equals 0, we obtain the asked result. We use the same technique for the second case. The second method for question 2 consists of using the fact that g is continuous and strictly increasing on the interval 0, 1. So we get g of 0, 1 equals minus infinity 0. Means that all images on this interval are negative. Use the same technique for 1 plus infinity. Part 2, question 1. The right-hand limit of the function f at 0 can be calculated directly using classical limits and the usual logarithmic limit of ln on the right at 0. Limit f of x at 0 plus is infinite. This means geometrically that the line x equals 0 is a vertical asymptote for the graph C. In sub-questions of the question 2, all the limits we are looking for can be calculated directly using classical limits and the two usual logarithmic limits, limit ln of x when x tends to plus infinity equals plus infinity, and limit ln of x over x when x tends to plus infinity equals 0. The nature of the infinite branch of the graph C near plus infinity is obtained through the three limits calculated in 2b. In question 3, sub-question A, we know that f is differentiable on 0 plus infinity. Then we calculate f prime of x using operations on derivatives and some usual derivatives like 1 over x prime equals minus 1 over x squared and ln of x prime equals 1 over x. Then we check that f prime of x equals g of x over x squared. Question 3b. The sign of g of x is obtained from part 1, question 2. The sign of f prime of x depends only on g of x because f prime of x equals g of x over x squared and x squared is strictly positive. Monotonicity of the function f is linked to the sign of its derivative f prime of x. In question 3c, the variations table of the function f is easily obtained from the results of the previous questions. In question 4a, we consider x belonging to the open interval 0 plus infinity, and through successive equivalences, we get the solutions set of the designated equation. Just note that ln of x equals 0 means ln of x equals ln 1 means x equals 1. Question 4b. To study the intersection between the curve C having equation y equals f of x and the line D having equation y equals x, just solve the equation of f of x equals x. This equation is equivalent to the equation of the question 4a. Since x equals 1 or x equals 2, then C and D are intersecting in exactly 2 points, E1, 1 and B2, 2. Sub-question 4c. Successive implications beginning from x belonging to 1, 2 and up at f of x minus x less than 0, and that is what we are looking for. The inequality f of x less than x for every x belonging to 1, 2 means graphically that the graph C is under the line D on the interval 1, 2. Question 5. To sketch the curve C, specific steps must be followed. Firstly, a well-done coordinate system, the vertical asymptote x equals 0 and the straight line dy equals x. Secondly, the graph C admits a horizontal tangent line at the point 1 f of 1 because the derivative f prime of x is null at 1. Then we sketch the graph C according to the variations table, the vertical asymptote and the parabolic branch near plus infinity, while taking into account the relative position of the graph C and the line D, and also the given inflection point. In the sub-question 6a, we calculate the wanted integral by transforming the expression ln x over x into ln x times ln x prime, and thusly getting a primitive through a usual formula. In the sub-question 6b, we need firstly to check that capital H is differentiable on 0 plus infinity, and secondly show that the derivative of capital H is exactly little h. So we deduce that the function capital H is a primitive of the function little h on 0 plus infinity. With the sub-question 6c, the integration by parts we will use is based on the fact that capital H is a primitive of little h, and the derivative of ln of x is 1 over x. During the calculation, we come across the integral of the sub-question 6a. In the question 6d, we use the classical formula of an area delimited by two curves and two vertical lines. The relative position of the graph C and the line D on the interval 1, 2 allows us to eliminate the absolute value in the integral. After that, we get the integral of 6c. Just calculate the measurement unit of the surface and get the asked area. Now we move to numerical sequences in the part 3 of the problem. Question 1. We have to use a proof by induction to show that un is between 1 and 2 for every n belonging to set n. Step 1. We check easily that this property is true for n equals 0. Step 2. We consider n belonging to set n. We suppose the property true at n, and we have to show that it is also true at n plus 1. To make this process easier, just use the fact that f is strictly increasing on the interval 1 plus infinity. According to the induction principle, we deduce that un is between 1 and 2 for every n belonging to n. Question 2. To show that unn is decreasing, we use the facts that for every n belonging to n, un plus 1 equals f of un belongs to the interval 1, 2, and for every x belonging to 1, 2, f of x is less than x from the part 2 question 4c. In question 3, the sequence unn is convergent because it is decreasing from the previous question, and it is also bounded below by 1 from question 1 part 3. Thusly, its limit L exists and it is finite. To find the value of L, we have firstly to check the 5 usual conditions. After that, we deduce that f over L equals L. L is a solution of the equation f of x equals x. So we get L equals 1 or L equals 2 from question 4b part 2. The sequence UNN is decreasing, so all of its terms are less than its first term square root of 3. Its limit also is less than square root of 3. That's why we eliminate 2 and conserves L equals 1. I hope you enjoyed this video. Don't forget to see my other videos. See you next time.